Hello, my name's Todd Gooch. I'm the author of the Gravitational Unit Theory, Unified Field Theory, and continuing on with my review videos. At the end of the video series that I'm giving right now, I'm going to do the theory of everything and do sample problems of all the four forces using a single equation. So be sure to stay tuned for that. Until then, I'm going to continue to go over the theory as it is today. In my last video, I was talking about the symmetrical gravitational octahedrals, and I needed to go over that a little bit before I moved on. The gravitational units, as a consequence of their permeable spherical geometry, naturally arrange themselves as octahedral polygons, gravitational octahedrals, with a doceptahedral or 14-sided configuration. Here are the front and top views and the back and bottom views of a gravitational symmetrical octahedral. I then went on to, might as well just show you that real quick, to do the geometry of the photons. These are cross-sectional views of the photon. That's the orange photon, the yellow photon, green photon, blue photon. They're all using the same symmetrical gravitational octahedral geometry. And finally, the violet photon, which took me about 3 hours to do right before an art class. We won't go into that. And then I went on to show how it broke into the rainbow. Again, reason why I was going over that was because the atoms have the same basic shape, the symmetrical gravitational octahedral shape, except one of their sides is dimpled in because it has a greater region of density and gravitation and becomes non-symmetrical, and the atoms are the non-symmetrical gravitational octahedrals. That applies for the first three periods, and then as you go on to the fourth and fifth, they have a geometry that's more complex. 18 valence electrons, and then 32 in periods 6 and 7. The atomic nuclei, non-symmetrical gravitational octahedrals, are represented geometrically. And I'm going to switch books at this point. I'm the only person I know of that has his own copyrighted periodic table, which I'll be giving to you most likely towards the end of this, after I show you where the information came from. And that's the geometric constructions of the atoms. Here's hydrogen top view. And notice the dark triangular electron phenomenon on the top of hydrogen. And here's the bottom of hydrogen. It's not drawn exactly as I'd like it to be. It's been many years since I drew it. I would probably draw it with the intersections just slightly larger than what they actually, such as the area of the white triangle would be larger than what it is, because this is also a bonding site. Hydrogen has two bonding sites, and this is supported by the bonding in the cycloboranes. In the cycloboranes, hydrogen bonds to two boron atoms constantly. And I'm the only person in the world that can draw B10 H16 correctly without, I mean, my theory has always called for the bonding in hydrogen to have two bonding sites, so it was no surprise to me. But apparently, the standard model does not it's unable to, with one bonding electron, explain this. So this is a case where my theory um, is following the data, while Lewis structures are not. Um, well, their model of the atom, the model of the atom that currently the Bohr model, um, etc., is not supporting the data. The Lewis model that hydrogen has two bonding sites, and mine certainly has always done that. Now this is helium. Uh, Notice how flat it is. This is what I mean by a non-symmetrical gravitational octahedral. It's flat. At least one side's crunching. It's not symmetrical on all three axes, like you have with the photons and the symmetrical gravitational octahedrals. So here's how your atoms are formed. Again, this is period one. Now we jump up here into period two, into lithium, the first atom in the second period. And what you see is I've got the previous geometry of the helium atom here that this geometry, this larger valence geometry, builds upon. And so you have to have this geometry to build this geometry. And so the whole um, the concept of your electronic configurations then builds on the previous geometry that was there before, and it gives me perfectly linear electronic configurations all the way to the seventh period, whereas the Aufbau principle fails chromium fourth period. Um, so again, here's a case where my theory is uh, better than the standard model. It is giving data that you want to see. You want to see that linear configuration. That's what everybody's looking for, and this is how you get it. And I have the only copyrighted periodic table that reflects that. I copyrighted it in 2007. It wasn't that easy to get a copyright on it. I had to basically tell them that, hey, if you don't have these pictures, you can't get those those configurations, which I'll be giving here in a few moments. There's lithium front view and lithium back view. Um, Again, you can see the internal geometry that's required in order to get this external geometry here, and that's how the linear configurations are. Uh, I'm able to get them. Here's beryllium. This is one of the most complete sets of um, the atoms that I have. It's from a very early version of my work, and I'd certainly like to reincorporate it into some later books, possibly my next book, which I'm considering calling T.O.E. It actually has a little bit more of a name to it. I don't want to give the whole thing away. Anyway, here's carbon. I don't want to just skip over carbon here. Carbon, if you see that, at the top, it's got its one bonding electron, which is a triangular electron phenomena. And I've recently been able to discover some data that's supporting that, from actual photographs of this, that it is triangular, and one of the sides is predicted to be a little bit off, and the other two sides are supposed to be the same, and that's really kind of what I'm seeing in the pictures. It's so small, hard, you know. I mean, they're lucky to get a picture. Anyway, here's the top electron, and here are the two or three bottom electrons, giving you the tetrahedral arrangement for carbon. You can get a really good idea. You can really see the internal geometry here for helium that it builds on. Here's the front view. Notice how flat it is. Showing the non-symmetrical nature of the gravitational octahedral. Moving to nitrogen. These are beginning to be what's known as keyhole elements, where the keyholes are the bonding sites instead of the keys anymore. Good example here would be the oxygen. See the keyhole here, and then the keyhole here. Before that, we were bonding with the keys, the dark triangles, but now what's going on is that these are the keyholes. The hydrogens for water, the keys will come down and they bond into these keyholes, and then you can see the back or the bottom view of oxygen, and you know it's got all these keys. They're all filled up, but they aren't the bonding sites. The bonding sites are here. They're the keyholes, and this is key and keyhole theory. And the idea is to insert keys into keyholes to make molecules. And we'll go over that later, but I really had to do this work with you before and show you the geometries of the atoms and the photons before I can move on into the more complex nature of chemistry and bonding. Trying to get a good focus for you guys. Doesn't want to focus real well. I'm going to move on. See if I can't get a picture over here. There it is, fluorine front view. That would be the bonding keyhole on fluorine. Notice over here the dark triangles all fill a fluorine up. Here it is again, right? That's the same one. There's only one of them on fluorine. And that was the bonding site. Neon. The inert elements, non-reactive elements, non-reactive because there's no flow, no electrical flow that's going through, electromagnetic flow going through this. It's really an electromagnetic gravitational flow that causes bonding to occur. Neon front view. Neon back view. Again, argon. I started to skip, I was able to, because it gets very complex and it's not that easy and it's very time consuming to actually draw these. So I started to summarize the periods by doing the inert elements because they do sum up the complete geometry of the period. Here's krypton top view and krypton bottom view. Notice how the geometry changed to an 18-sided geometry. And when I say that, I mean there'll be 9 here, 6, 3, and 3 here, and then again the same kind of thing here. The geometries are the same for the 4th and 5th periods, and then the 6th and 7th periods. It took me 3 weeks to actually get the geometry of radon, and of course also element 118, which I'll talk about here in just a moment. I'm going to skip back to the other book. I have a bookmark I want to go to. This is my copyrighted periodic